We have a 15 kilogram block and it's being pulled to the right with a force of 100 newtons, but not directly horizontally to the right, but rather at an angle. The angle is 14 degrees to the horizontal. We can see that the surface is not frictionless because we are given the coefficient of friction, kinetic friction, for this situation as 0,4. And what we're asked to find out is the block's acceleration. So what you need to do at this stage is to use this strategy, substitute numbers into the various variables given here, and solve for acceleration. Once you've done that, then proceed with the movie. Until then, pause the movie. So we first need to find the normal force. F net y is equal to 0. We let up be positive. 0 is equal to normal plus Fy minus W. We rearrange this to give us normal equals W minus Fy. So now normal is the subject of the equation. We substitute values into this. W is 15 times 9,8 and Fy is 100 times sine 14 degrees. We do the calculation. The normal force here is 122,81 newtons acting upward. The reason why we needed to find the normal force was so that we could find friction force. So we substitute that value that we got, 122,81, into n within this equation. We know that the coefficient of kinetic friction for this situation is 0,4. That was given in the question. So we multiply that with the normal force, and that tells us the magnitude of friction acting on the block. 49,12 newtons, and we know that the direction is towards the left because the object is moving to the right and friction always acts in the opposite direction to motion. The reason why we needed friction was so that we could work out the net horizontal force acting on the block. And there are two forces acting horizontally on the block. They are the x component of the applied force acting to the right and friction acting to the left. We let right be positive, so Fx is given a positive value, and we subtract friction which acts to the left from this. So we substitute values into that. We know friction, we calculated it just now, it's 49,12. We know Fx is 100 times cos 14 degrees. We do the calculation, the answer is 47,91 newtons to the right. The reason why we calculated this was so that we could find out acceleration. Acceleration is equal to F net. In this case, it's in x direction, since acceleration is in the x direction, divided by mass. So we can substitute values into that. 47,91 is F net x. We know the mass is given in the question, 15 kilograms. We do the calculation. We find our answer, 3,19. We know that the unit of acceleration is meters per second squared. In other words, meters times second to the minus 2. And the direction must be the same as the direction of the net force causing the acceleration. And we saw that that was to the right, so the acceleration is also to the right. And this is our final answer that we were asked to solve. So we underline it.